So you work as a developer and you just finished the job of instrumenting all your microservices, and they are currently producing telemetry data such as traces and metrics. But the observability team is asking for that data. So how can you actually collect all this produced data and send to the observability backends? In this video, I'm going to show you how to implement the OpenTelemetry Collector that's going to act as this processing engine that's going to receive the telemetry data and send to the compatible observability backends. Let's do it. Hello there and welcome. My name is Ricardo Ferreira and I'm a developer advocate here with AWS. In this video, I'm going to show you how to implement the OpenTelemetry Collector. The OpenTelemetry Collector is one of the key components of the OpenTelemetry architecture because it acts as the integration and processing layer that receives telemetry data and sends to the compatible observability backends. For those of you that never have heard of OpenTelemetry Collector, I'm going to give you a quick overview before we jump into the implementation aspects of it. The best way to understand the OpenTelemetry Collector component is to go back to the fundamentals of observability. When you implement observability, you're always going to have three main phases: the phase of data collection, the phase of data processing, and the phase of data transmission or data storage, if you will. In the data collection phase, you are going to basically pick up the data from the sources, whether those sources are going to be your applications or microservices. And you are going to do so using some specific technologies of data collection that's going to talk with one specific protocol or one specific technology, such as OpenTelemetry. So in this diagram, you can see here that we have the sources represented by some technologies and protocols, such as OTLP, which is the protocol for OpenTelemetry, Jaeger, which is a very popular distributed tracing technology, and Prometheus, which is another very popular technology, but focused on metrics. Those are the sources where the telemetry data will be captured from. Once they are captured, they need to be received and processed. By process it, I mean you have to actually make sure that you are going to put them in the specific format or standard that's going to be ready to be transmitted or stored in some observability backend. Sometimes this requires you to perform some message transformation. Sometimes this requires you to do some message buffering. And even sometimes this requires you to make some data discarding because maybe some of those events or raw data are not in appropriate format, or maybe they are repeated. So the role of this phase of data processing is to make sure that the data is ready to be transmitted and stored in the observability backend. Then you are going to have another phase of export data, but to actually send to the interested parties on that data, which is going to be namely the observability backends. You can do this just like you did in the data collection phase using different technologies and protocols. And here you can transmit the data using OTLP, or maybe you are sending data to Jaeger, and perhaps you are basically aiming to store some metrics and Prometheus. Regardless, this whole architecture can be comprised and represented by this technology called OpenTelemetry Collector. So what is OpenTelemetry Collector? Is going to be this middleware component that's going to do the job or receive, processing, and transmit the telemetry data that has been collected by the sources. And the main characteristic of the OpenTelemetry Collector is extensibility. So it should be able to support many standards, many technologies, both for data collection and for data transmission. So you're going to see that when we're going to start actually implementing the OpenTelemetry Collector, you're going to see that you have the ability using a YAML file to specify all these technologies and the adapters that are compatible with the OpenTelemetry Collector. But what you have to always remember that the role of the collector is to actually be an essential part of your capture, processing, and storage of your telemetry data. Another key component of the OpenTelemetry Collector is to serve as this mediation layer and sometimes even this kind of a separation layer between your microservices and the observability backend. So what that means is that even though some observability vendors might be compatible with the technologies or formats that your microservices are sending the data, OTLP, for example, still might be interesting to use the OpenTelemetry Collector in between them. Why? Because it's going to act as a layer of decoupling. So this might be interesting if you, for example, start using one specific observability backend, and then in the future, your organization decides to replace for another. And because now they are decoupled by the OpenTelemetry Collector, you can change the observability backend without necessarily changing the code or sometimes even the configuration of your microservices and applications that act as the sources for the telemetry data. Another usage of the OpenTelemetry Collector is to act as the kind of a local receiver that's going to be running side by side with your source application, such as let's say, for example, you are dealing with an environment that has unstable networking. And then sometimes your telemetry data is trying to transmit the data, but because of the network connectivity issues, is not being able to complete that transmission. So if you can use the OpenTelemetry Collector running side by side with your microservices, you're going to eliminate that possibility, because another characteristic of the OpenTelemetry Collector is its ability to actually buffering the telemetry data before transmitting to the backend. So in a worst case scenario that your backend your observability backend becomes unavailable, the OpenTelemetry Collector can act as this buffering layer that's going to save the telemetry data before the transmission to occur. So there's a lot of advantages for you to actually using the OpenTelemetry Collector. So let's take a look right now how you can start using it in your implementation for observability. So let's get back to the implementation of our microservice. If you're new to this series, take a look here on the comments below, and you're going to find a link of the GitHub repository that contains the implementation of the microservice that we're using for demonstration purposes. Just be mindful that we are using a specific branch called Build on AWS Tutorial. So when you clone that repository, clone that branch specifically. So we're going to start the development of our OpenTelemetry Collector by creating its configuration file that is going to be written in YAML. So I'm going to create a new file in the project, and I'm going to call this file collector config local YAML. So because it's YAML, we have to write the code using the YAML standard. So be ready to use lots of tabs and spaces while we're implementing this. So as you can see here, the OpenTelemetry Collector configuration file is basically broken down into three main sessions: the receivers, the exporters, and the service pipelines, right? There might be other sessions that are also supported on the OpenTelemetry Collector file, such as extensions and other plugins that you can use with it. But for the very minimal implementation of the OpenTelemetry Collector, you're gonna have to use these three sessions. So the receivers, as the name implies, is going to be the one or multiple endpoints that you are going to expose for the source applications or source microservices to send data in. So this is how you actually make the functionality of the OpenTelemetry Collector available for the outside world. The exporters are going to be, like the name implies, what are going to be the sinks, or where are you going to send the data to. So as you can see here, we're basically using logging. So we're going to export all the received telemetry data to the logs, just like we did in the previous videos where we configured the exporter for the microservice to flush all the telemetry data to the logs. And as for the receivers, we're going to receive this telemetry data using the OTLP protocol, which is the protocol for OpenTelemetry. And then once you have your receivers and exporter configured, you're going to use them here in the session called service, where you're going to define your pipelines. So in here, I am defining a pipeline called metrics that basically is composed by receivers and exporters. And then you're going to have an array of one or multiple receivers and an array of one or multiple exporters. Same goes to traces, right? So now that you have a OpenTelemetry configuration file in place, what we're going to do is actually execute this using Docker, right? So since this file is on the root folder of our implementation, I'm going to essentially execute my my Docker. I'm going to create a Docker container, right? And I'm going to provide that collector configuration file as a parameter for it. So internally, that container is going to bind that file to this specific location inside the container image. And as you can see here, we're going to expose the port 5555, which is going to be the port that our microservices are going to send the data in. Remember, we're actually the collector is exposing an endpoint using OTLP. And if you see here what we have done in the configuration file, you're going to see that we're exposing the endpoint over the port 5555 and all the network interfaces from that container. So that's why we are basically doing this rebinding of the port 5555 here. And then we're going to use the image for the OpenTelemetry Collector. So if we run this, you're going to see a bunch of verbose information being printed out, but what matters is this last message here. Everything is ready, begin running the processing data. It means that the container is ready to go. I mean, it's ready to receive the data and execute that pipeline that you've defined it on the configuration file. So let's take a look if this is true or not. So I'm going to open another terminal here, and I'm going to send a message. No, actually, I have to, let's take one step back. I have to first execute our microservice because currently it's not running. And then I'm going to send a message to that microservice that in turn is going to send the data to the OpenTelemetry Collector. But for this to happen, I need to tell our microservice that now it should not send the telemetry data to the login, because remember, in the previous videos, we configured the exporters to send the data to the login. Now we have to tell the microservice to send the data to the OpenTelemetry Collector. So what we need to do is in the run microservice.sh script that we use to execute the microservice, we're going to change its implementation to do a specific set of exporting of the environment variables. So instead of using the export to logging as we were doing before, we're actually going to do this. So basically we're telling the script to set the exporter for traces and metrics to the OTLP protocol. So now we're telling them, hey, forget about the whole logging story that we were using before. Now focus on send the data compatible with the OTLP protocol. And then we're giving it the endpoint for where to send the data in, which is going to be localhost because we rebind it in a Docker container over the port 5555. And we can also decorate some of the kind of metadata for our services and set the version of it. This is going to be useful for whoever is looking to do observability backend to identify your microservice while looking to the services, the traces, and the metrics on it. So now that we have changed the script of our microservice, we can go back to what we were trying to do before. So just to recap, we have this container up and running here, which is the OpenTelemetry Collector. And now we're going to execute our microservice. The microservice is going to do what it was doing before, run the Maven build, and then execute the actual code for the microservice using the jar file. But remember that we're still using the automatic instrumentation, so black box instrumentation. So it's going to use the agent that we've implemented in previous videos. Now we have the OpenTelemetry Collector running. We have the microservice running, and the microservice has been instructed to send whatever telemetry data generated now for the collector. So what we're going to do now is open a third terminal. And now finally, I can send the message to the microservice. So let's do this in a curl command. Let me get the history here. I have one ready to go. So this is the message that I've sent to the microservice. The microservice, as expected, reply back with, hey, hello world. But the interesting part is that if we go back to the logging of our microservice, you won't be able to see anymore all those loggings that were available before we made the change to send the telemetry data to the collector. Now it basically is going to do the logging for the actual microservice. This the response is valid, is actually part of the code of the microservice. But if you go back to the logging of the collector, you're going to see some interesting entries here that represents the all the traces and metrics and all the information that are already coming from the microservice. You're going to see that the collector by default prints out the information in this kind of a specific format here. It's kind of a line by line field per line. So you can see the timestamp, the value. Those are metrics. You can see by the word data point attributes. But what matters is that you can clearly see now that your collector is receiving and processing the data. So what I mean by processing is basically is passing through, right? It receives it, and since we haven't defined any processing logic for the pipeline, it's simply delegated from the receiver to the exporter. So if we go back to the configuration file, you're going to see that what is our pipeline for traces, for example. Basically, we're going to receive, and then since there's nothing in between, we're going to simply export to the logging. Hence, why you are seeing all the information in the logging of the of your OpenTelemetry Collector. So now that we have our OpenTelemetry Collector properly executing, what I'm going to do right now is to stop the collector and the microservice, because it doesn't make any sense to keep them both up and running. And I'm going to actually include the definition of the collector along with the observability backend. So the next time we spin up our observability backend, we're also going to execute the OpenTelemetry Collector along with it. So let's go back to the terminal. So this is the, I'm gonna close this terminal. I'm gonna finish the execution of the microservice, and then I am also going to finish the execution of our Docker container, because it was an on-the-fly execution of the Docker container, right? So now that we have done this, what I'm actually going to do is to include the definition of the collector along with our Docker compose file. So just to recap, the Docker compose file right now includes the definition of the Grafana temple, which is our tracing backend, includes the definition of Prometheus, which is our metrics backend, and includes the definition of Grafana, which is our visualization tool. So what I'm going to do now is to include another definition for the collector. So since we have to be mindful with tabs and spaces, I'm going to do this, because now the definition of the collector is in line with the other services. So as you can see here, we are using the same image that we've used before, container name collector, hostname collector, and we're going to create a dependency on Grafana temple and Prometheus, because we do want that the collector kind of awaits for the observability backends to execute first, so it can actually start its execution. Why? Because ultimately in future videos, you're going to see that we're going to configure the collector, we're going to change its pipeline to send the data to Grafana temple and Prometheus. And as you can see here, we are doing the rebinding of the configuration file locally to that location inside the container image for the configuration file. And we're re-exposing the port 5555 and 6666. This port here is going to be used in future videos, so I'm not going to spoil the definition right now. I'm going to wait for you to actually go back to the series. But for now, just let's recap. We've created a definition of the OpenTelemetry Collector using a YAML file. We've defined the pipeline. We've executed a container, and then we've changed the script of the microservice to start sending the data, the produced telemetry data, to that collector instead of the logging. And then finally, when we saw that everything is up and running and working as expected, we stopped the execution of everything and included the definition of the collector along with the observability backend. In the next videos, I'm going to show you how to change these configurations to make things a little bit more interesting in terms of how to transmit the data to the actual observability backends. Until there, I hope you stay safe and see you next time.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.